Hello, everyone. Thank you for joining the California State Library's Government Publications section for a very special presentation on the climate change phenomenon known as tropicalization and the challenges and opportunities of working across borders at the Tijuana River National Estuarine Research Reserve. My name is Emily Mackinson, and I am the host of this afternoon's event. I am a librarian in the Government Publications section of the California State Library. We have a co-host this afternoon, Bradley Siebold, who is also a librarian in the Government Publications section. Bradley will be monitoring our Q&A section throughout the program for any questions you may have for our presenter, and he will read your questions during the Q&A session at the end of the presentation. The California State Library is thrilled to partner with the California State Parks to present today's program. Our presenter today, Dr. Jeff Crooks, is joining us from the Tijuana River National Estuarine Research Reserve, which is located on the California coast just north of the international border between the United States and Mexico. Jeff will be telling us more about tropicalization, a climate change phenomenon in which warm water species expand into cooler areas where they were previously rare or absent. Today's program expands upon a discussion of the challenges of addressing tropicalization across borders, first heard in an episode of the Tijuana River National Estuarine Research Reserve's podcast, Divided Together. Divided Together is hosted by Anne Marie Tipton, Education Coordinator with California State Parks at the Tijuana River National Estuarine Research Reserve. Anne Marie was unfortunately unable to join us today, but you can check out additional episodes of Divided Together by following the link we will be posting in the chat or by searching in your favorite podcast app. The California State Library is also pleased to partner with the California State Parks for our California State Library Parks Pass, which allows public library patrons to check out a pass for free vehicle day use entry in participating state parks. Now, before we begin, I have just a few points of housekeeping to go over. If you have any questions during the presentation, please type them into the Q&A box and we will answer them at the end of the program during our Q&A session. This presentation will be recorded and made available in the coming days. Live transcription is enabled, so if you'd like to see captions, please click the CC icon to show subtitles. If you run into any technical difficulties during the presentation, please put those in the Q&A box and we will try to help you if we can. Finally, we have added links related to the California State Library, California State Library Parks Pass, and the Tijuana River National Estuarine Research Reserve in the chat window. For any state employees without a library card, please consider applying for one through the posted online application link. Now that housekeeping is out of the way, let's get to the main event. Our speaker today is Dr. Jeff Crooks. Jeff has been the research coordinator with the Southwest Wetlands Interpretive Association at the Tijuana River National Estuarine Research Reserve since 2002. He is a native San Diegan who started working in the area's coastal wetlands in the late 1980s. He has a Bachelor of Science from Colorado State University, a Master of Science from San Diego State University, and a PhD from the Scripps Institution of Oceanography. Please join me in welcoming Dr. Jeff Crooks.
All right, well, thank you very much. I see I'm wearing the same shirt. I did not plan that, just the way it sort of worked out. All right, well, thank you very much. And I'm happy to have a chance to present this afternoon and share some of the things we've been thinking about here at the Tijuana River National Estuarine Research Reserve. And let me just get this going. Okay, we're looking good. Yeah, all right, very good, thanks. Yeah, so today I'll be talking about this issue of species on the move down here in the border area, and especially around this idea of tropicalization, which Emily had mentioned, and see if we see signals of a warming climate in the way species are responding. Just a little bit of background. Again, Emily provided some of this. I'll just provide a little bit more. Um, I am part of the National Estuarine Research Reserve System, which is administered by NOAA, the National Oceanic and Atmospheric Administration. The National Estuarine Research Reserves are federal state partnerships and established by the Coastal Zone Management Act of 1972. And they're really set up to be places that we can improve our understanding of estuaries so that we can better manage them. They serve as living laboratories, and we try and practice and promote coastal and estuarine stewardship through research and education with this system of protected areas. There's 30 research reserves around the country. Ours is unique as it's the only one on a binational watershed. It's managed at the state level by California State Parks. I work for a nonprofit, the Southwest Wetlands Interpretive Association, and much of the reserve is actually a National Wildlife Refuge. So the Fish and Wildlife Service is quite involved. So here's a picture of the watershed, this binational watershed, about 1,700 square miles. 2/3 of it, or almost 3/4 of it, is in Mexico. The lower portion of the valley here is solely in the U.S. And most of what I'll be talking about today, the estuarine portion, is in the United States. You know, I've been calling this a binational watershed. That's actually incorrect. The indigenous tribe, the Kumeyaay, the whole of this watershed and much more, this is their ancestral land. So they have some reservations in the watershed, but really this is the ancestral land of the Kumeyaay. So we like to talk about one border, three nations, all meeting here at our location. So again, as you heard, there was a podcast put together to hit on some of these themes, divided together. And one of the primary themes is this, the importance of working with the Kumeyaay. So here's a list of the podcast episodes that are available. And today I'll be talking about this one that I was involved in. This scientists and geographers working across borders, and I will provide some more information on that. Okay, what we're talking about when we're speaking about tropicalization and species getting to a new area, however they get there, is really an issue of what we call biological invasions. It's the arrival of a species into an area in which it did not exist in historical times. So just a species getting to somewhere it didn't used to be. As long as species have been on the planet, they've been moving themselves around. So invasions are fundamentally natural events, but much of what is happening now has been influenced by people, including this issue of tropicalization, these temperate species moving northwards. So there's a lot of discussion about terminology and that we use with this is exotic, non-native, invasive, that sort of thing, range expanders, that kind of business. I'm not going to really get into that too much today. Hopefully it's clear from context what I'm speaking about, but I do think what's important about this is not worry so much about definitions, but think about invasions as a process where something starts out in one location, ends up somewhere else, and becomes successful. So I think you can consider the invasion process occurring in 4 different phases. Movement is where the species get from point A to point B. It's dispersal. The arrival phase of invasion is it gets to the new place. The establishment phase of invasion is survival to form reproductive populations. And then the final phase is spread and integration. So once it gets at its new location, the species spreads around and begins to forge ecological interactions. So in this movement phase of invasion, a lot of what we think about is humans doing the work, moving things around. But in reality, species they can swim or walk or crawl or float or fly, right? It's just about a species getting from one place to another. But there's a lot of good reason to float on what we call these anthropogenic introductions, where humans are the ones modifying the way species are getting around. We've dramatically increased the rate, the routes, the speeds that we're moving species around. Species are getting to far-flung places that they would very, very unlikely be able to reach naturally. So I put up here on the left a map of that I pulled up a couple of weeks ago of all the vessels, of all the ships at sea at on this day a couple of weeks ago, showing this sort of immense traffic on the world's oceans. And this is just one means of travel. But on those ships, there's things living on the hulls, there's things in the ballast water, the ships are moving around cargo. There's all sorts of things being moved around. So there's good reason for us to focus on these anthropogenic introductions where we're doing the movement. And I will talk a little bit about that today. Again, partly because there's such an important phenomenon in the ecological perspective. It's estimated that about 60% of worldwide extinctions, non-native species, these anthropogenic introductions, have played at least some sort of role in that. And the economic costs associated with invasions is rapidly rising. Just a few years ago, it was over $400 billion a year. So again, there's a lot of good reason to think about these anthropogenic introductions where we're doing the moving. But there's another part of this. So once the species arrives in a new location, it has to find itself somewhere comfortable and familiar, right? Is it warm enough, wet enough, cool enough, dry enough, right? So even though a species gets moved from point A to point B, it has to, for a successful invasion to occur, it has to survive to form reproductive populations. And this is another really critical part of the invasion process. And again, one I'll be talking about today. So there's natural processes at work here. But of course, humans are doing a lot to affect this as well in terms of global climate change and warming and things like that. So, so these changes to the local environments that might make them more receptive to species arriving can happen at the global scale, but they often play out locally. So that's what I'm going to spend the first little bit of the talk today speaking about is invasions sort of at a local scale in the Tijuana River Valley. So as I've mentioned before, the geographically, the Tijuana River is a fascinating place to work where the three nations come together, right? But this estuary and other estuaries like it are the one place on Earth where land, sea, and fresh water come together, right? These are the only ecosystems on Earth where this happens. They're very dynamic, complex, interesting systems. When we're thinking about invasions, we have to consider invasion, species moving in from all sides. So that's the theme for the first part of the talk today. And to talk about this, I'm going to talk about this piece of wood I found sitting on the beach a few years back, about 6 years ago. And when looking at this thing and the condition it was in, it made me realize that for this log to be here in this state really represented a series of different invasions in the Tijuana River Valley that encompass invasions from the land, sea, and fresh water. So I'm going to start then with talking about changes and invasions associated with fresh water, the rivers. So we're really fortunate in the Tijuana River Valley to have a historical ecology study done led by the San Francisco Estuary Institute, done a few years back, and it painted this really nice picture of change in the river valley over the last 150, 200 years or so. And this is available on the web for free. You can go to our website and download it. It's a really nice document. And one of the things that this document shows is there's been substantial changes in the middle part of the valley here. It moved from a largely dry, arroyo, scrubby sort of habitat, which is typical for this region. We don't get very much rain. less than 10 inches a year, Mediterranean climate. It all comes during relatively few events during the wet season. And then we have a warm, dry summer season. So the old quote about Southern California rivers where you fall in and you come out dusty, that was the characteristic of this system. That has changed though. So what we currently now is this dense, what we call a riparian forest. So that's the trees associated with a river zone, not necessarily grown in the river itself, but in the forest that's in the floodplain. And this forest is relatively new. This wasn't here historically. And as a result of changes that have occurred in the river valley. So again, we think the nice part about this historical ecology study is that it not only sort of documented how things changed, we tried to get out why things changed. And we have a sense of what drove the growth of this forest, this willow forest, one of the trees of which ended up on the beach. So again, the natural state of the system here, when we think about flow permanence, how much is the river flowing? For the most part, rivers in Southern California tend to flow, especially as far south as we are, only when it's raining, especially at the coast as well. And then during the dry season, there's typically no flow. So we know that in general, but we have a pretty good record of flow in the Tijuana River for the last almost 100 years or so. And we can see there's been a few years where the river would be flowing year round, but for the most part, no. But most part, there was relatively little flow. And at that time, the dominant habitat type was this riparian scrub, the one I just showed the picture of. Starting in 1980, things really started to change, and suddenly we turned this ephemeral river, this river that would not flow year-round, into a perennial river. Now, there's a couple things that happened around then. The climate actually changed a little bit. It got a little bit wetter, but really importantly, the city of Tijuana was starting to grow. And in the early 1980s is when the aqueduct from Tijuana to the Colorado River, well, from the Colorado River to the Tijuana was completed. So we essentially had Colorado River water being ported into Tijuana, and some of that running off, coming downhill, largely sort of contaminated, polluted water coming downhill and growing this riparian forest. So this is a picture of what it looked like in 1979. No real forest, no real trees. Just a few years afterwards is when this willow forest started to grow and turned into the forest that we have now. And again, in some ways, it's largely fueled by the Colorado River. So there's a lot of thinking about the impacts of diverting the Colorado River, and rightly so, and not flowing into the Gulf of California. But there's also impacts to places where that water ends up, especially in these drier areas in Southern California. It doesn't take a whole lot of water to convert it from one type of habitat to another. So management-wise, this is a pretty major disturbance to the system, but we're fortunate in that the primary species that grew up was a willow species, native species, that actually are a really important resource. And it's estimated that about 95% of the riparian zone like this in Southern California has been lost. So the fact that this riparian forest invaded the Tijuana River Valley because of a change we made in the receiving environment, through adding water, we helped the tree establish, doesn't necessarily mean it's a bad thing. And it's in fact, it's considered a resource, and it supports an endangered bird, the least Bell's vireo, right? So it's not necessarily a case an invasion is a bad thing. It completely depends on context. And yeah, so that's then what allowed this tree, this willow tree to grow. This increasing freshwater flow, disturbance associated with that flow as well, some sediment coming in and bearing habitats, freshwater allowing these trees to grow, and then and having this forest. Okay, so what then knocked the tree down, and not just knocked this tree down, but knocked a whole lot of other trees just like it down. And that's the story of another invasion, which is an invasion from the land. right? And this is a case of an anthropogenic introduction where we're doing the moving. The last example was one where we're changing conditions, allowing a new species to come in. This is an example of we as humans are transporting a species across broad distances and putting it somewhere where it's not native. So that's an invasion from the land. Excuse me. So this is the creature that did the damage here is called the Kuroshio shot-hole borer. It's a tiny little ambrosia beetle about the size of a pencil lead, so very, very small and hard to see. It was probably introduced with wood products from Asia mid around 2015, 2016 or so. It's called a shot hole borer because it burrows into the trees and creates these little, looks like it's been shot with a shotgun, and it can really damage the trees. Interestingly, for me as a biologist, it's not actually eating the trees, it's burrowing around in the trees to essentially create a home. It's creating these burrow networks that it's these galleries of burrows for somewhere to live, but also it has a specialized carapace here where it's gardening a fungus. So it's going around the trees, spreading a fungus around that it's growing, and then using it as a food source for itself and its offspring. And our native trees are not resistant to this fungus, and it can kill them and knock them back. It's called Fusarium dieback. Right, so this is this non-native species that got put in, a novel species that our natives don't have any sort of resistance to this fungus, and it's causing dramatic impacts. Interestingly, I think there probably is some signal of tropicalization here. The shot-hole borer is largely a tropical, found in sort of tropical Asia, from Okinawa down to Java. It's the pink dots here are the shot hole borers where it's native, and the pink here is where it's been introduced into the Americas. And it could be the case that it's finding a more favorable climate here in San Diego. So this is a graph of average annual temperatures in San Diego for the last, well, since the 1850s or so. And we can see from looking at the average annual temperatures, it's definitely much warmer than it used to be here in San Diego. So it could be when this beetle invaded, it found itself a more favorable habitat, which would be a signal of tropicalization. We don't know exactly if that's the case, if it would have been introduced 100 years ago, whether it would have been whether it would have made it, but it's clear that we're changing the system in a way that might make it more favorable for tropical species. And I'll return to this idea in a little bit. So here's just a picture, some pictures of what the beetle did. And we have a story map on this on our website that you can feel free to check out. Here's a picture of the riparian forest, willow trees. You can't really see, but Mexico is right behind this. When the beetles came in just a few months, they really did a number on the forest, knocked them back, and you can see Tijuana on the hillside here. After after the beetle sort of did its number, it's still present, but we saw some recovery. Importantly, a lot of the things that came back were another non-native species, arundo, the giant reed, with the willow canopy. Had sort of been keeping those in check, and when the beetle came in, it knocked that back and allowed the sort of escape of another non-native weed. Now the willows are still coming back. There's still a lot of arundo, the non-native, in there. We're not sure what's going to happen next. The trees want a certain diameter to certain breadth of tree to be able to burrow into. So as these trees get bigger, they may get attacked again. So we're paying attention to what's happening. It's a relatively new invasion. Okay, so we know what caused the tree to grow, this increasing fresh water. We know what caused the tree to get knocked down, which was this beetle invasion. Again, maybe a signal of tropicalization here, this tropical species coming in. And then, well, what allowed, what is all this stuff growing on it? And that's the story of another invasion. One of the Pacific oyster or the Japanese oyster, a non-native species here in San Diego. And so that's an example of an invasion from the sea, which is what I've done most of my research on, is marine bioinvasion. So I'll talk about this a little bit and some lessons to be learned from this. So these oysters are really interesting. We do have a native oyster on this coast, the Olympia oyster, Austria lurida. It was harvested. It's an edible species. People started to over harvest it in the mid 1800s. It's also relatively small and grows a little bit more slowly than some other oysters, like the East Coast oyster, the Virginia oyster, or the Japanese oyster. So there was considerable effort before World War II, but especially after World War II, to try and get this Japanese oyster established on this coast. And so people brought in loads of oysters, spread them around on mud flats, trying to get them established. In the Pacific Northwest, it sort of worked. It became an important fishery resource and still is, and is grown in aquaculture settings. And wild populations established there. In California, though, the situation was different. There was rare instances of individuals that escaped, but basically it was considered that oysters grown here do not reproduce in these waters. So yeah, you can move them in, but they're not gonna take. But one thing about invasions is that you should learn to expect the unexpected. Things can change. They're really prone, invasive species, invaders are really prone to cause ecological surprises. So what we started to see in the early 2000s is this oyster starting to pop up all over San Diego County. And my kids and I, when they were younger, it was cool to hang out with Dad. They did science fair projects and things like this, and we went and checked out and see where this oyster was growing. And it was basically in every suitable system here in San Diego, and it's in other places as well. It's down into Mexico, but it's also in other places in Southern California, including winding up sitting on this log on the beach here in the Tijuana River in just a few years ago. Okay, so that oyster then is one of these introduced non-native species, but I've been trying to keep track of this for a while now. And we have over 125 known non-native marine species here in San Diego. And the rate of invasion seems to be increasing. So this is a graph of number of invasive species found over different time periods, and the rate of invasion seems to be going up. Now, some of that is because we are doing a better job finding these, and we have genetic tools and more monitoring, but it also is a quickening pace of invasion. We are moving things around much more quickly and efficiently than we used to. That may be leveling off a little bit. This rate of invasion of some of the other systems we're looking at might be flattening out a little bit, but still there's a lot of species that have been moved and are still being moved around. So what I want to spend a little bit of time now on is this jellyfish here floating over the 1980s to 90s, when this species was first found. And this is Australian jellyfish, Phylloryza punctata, that's been around for quite a while, but interestingly, it's one of these species that seems to do particularly well when the waters get warm. And when we have warm water, such as during an El Nino event, like we had in 2016, this thing seems to bloom and it's all over the place. And it shows up in the newspapers and on the news and things like that. And 2016 was right in the middle of one of what we call these marine heat waves, these periods of extended warm water. And it was called a variety of things. There was a warm water blob sitting off North America, and an El Nino event, which are characterized by warm waters. So, and of course, with climate change, we expect these marine heat waves to become more common. And there's this general idea that that invasive species might tend to be facilitated by climate change and warming, might help them spread around or become more invasive, become established and become more invasive. right? And so I just took a quick look at this really broad brush by some of the native and non-native sea squirts, ascidians, we have here in San Diego. It's a pretty well-studied group. And again, really coarse, cursory look. What I did is looked at the native range of these species. For the natives, it's obviously on this coast. For the introduced species, it's wherever it's from. Most of them are from Asia. And looked at what sort of temperature ranges were found where the species are from, right? What were the temperature conditions? And for the native species, of which there was 9, the average temperature range for a native species, the average range of temperature that a native species would be found in was about 14 degrees. Whereas this is Celsius. And in the average temperature range for the non-native species was quite a bit more than that, was 24 degrees. So non-native species tend to be found in a much broader temperature range than the native species. And similarly, looking at sort of the maximum end of the range, how warm of waters would these things to get into in really broad brush, sort of on average. The average maximum temperature for the natives was 22 degrees, 22 and a half, whereas the average maximum temperature for the non-natives was over 28 degrees. And this is Celsius. 28 degrees is about as tropical waters, about as warm as it gets. So this does suggest, at least looking at for these critters, that if conditions warm here, the natives may not essentially recognize it anymore. It might become less hospitable for them, and the non-natives will do better. And there's a reason why we think non-natives will tend to do better, right? The invasion process is essentially a filter. Things have to get picked up and moved around and wind up somewhere new, and you tend to weed out sort of literally the species that can't handle that. So we tend to move around species, or the things that tend to invade are the ones that are tough, that they can handle being a little bit warmer, a little bit drier, a little bit saltier, a little bit poorer water quality, that kind of thing. So there's sort of good reason to believe, why climate change might help invaders, and there's some evidence for this. And there's been other people have looked at this as well. I was just trying in a more sophisticated way. I was just trying to provide a local example for here in San Diego. So then this now is leading into this idea of tropicalization, right? So which is either rare warm water species becoming more common. So species that are already around, like this jellyfish, it's around, but when it becomes warm, we see more of it. Or the appearance of new species altogether. So species that weren't normally found in this area marching northward. So I've talked a bit now about sort of these non-native species, these introduced species. So now I'm going to focus on species native to this coast that are already found on this coast that either are becoming more common or look like they're becoming more common or have appeared altogether. So this is a graph adapted from a paper we wrote a couple years ago, led by some folks up here in the U.S. at the 2 research reserves, ours and the one in Elkhorn Slough, and the National Marine Sanctuary in Monterey Bay. Then a couple of colleagues down at OABC in Ensenada in Mexico, Rodrigo and Julio. And so this is a graph of average temperature over time in the Tijuana estuary. So we're really fortunate to have a long-term monitoring program where we've had data loggers out since '96, and every 15 minutes is telling us temperature, salinity, all sorts of things. So we can look at that record and see what's happening with temperature. So this is called an anomaly plot. And if the points are above the line, it means that it's above the long-term average. And if it's below the line, it's below the long-term average. And you can definitely see this marine heat wave here starting in 2013, 14, that sort of thing, that has been sort of exceptionally warm. And during that time, we have seen these warmer water species becoming more abundant. So we also have a biological monitoring program where we're out doing seining for fish samples or minnow traps, baited traps that you throw and see what swims into it or crawls into it. So I'll talk a little bit about that. So one of the species that we're interested in is called the long-tailed goby. It's a tropical goby that is known from this area, but is usually fairly rare. I had a student at the University of San Diego, Abby Biaja-Hudak, who looked at this, and she went out and did some sampling a couple years ago for over a year or two to see what was going on. This is one of the things she was interested in and found. But she also went back through the long-term sampling record that dates back to the late 80s, first done by researchers at San Diego State. And I was in on some of the early sampling for this. And then we took it over about almost 20 years ago and have tried to continue on with the sampling. And what she did is looked at it just presence or absence in the sampling effort, whether it was minnow traps or dragon fish seines, was the goby found or not? And for many years, it basically wasn't found. There was one time it was found in the late 1990s, which was associated with an El Nino. So the blue trace here is a measure of the strength of the El Nino Southern Oscillation Index. So the bigger it is, the stronger the El Nino. This is a very typical pattern for a lot of these species that we're seeing more of now, is it would be around once or twice during an El Nino, but then would disappear. But that's not what we're seeing now. We're seeing this continued presence year after year of these species that probably initially came up during the marine heat wave and then stuck around. The El Nino went away, but the species didn't, right? So which is a pretty interesting pattern. And one of the things that Abby focused on, which I thought was pretty nice for her master's thesis, was this idea of using species as indicators, because sometimes it's a little hard to know. When I said that last plot that I looked at, the average temperature difference in degrees Celsius was 1 degree, 1.5 degrees. That doesn't sound like all that much. I don't know if I would know the difference between 69 degrees and 70 degrees if I went on the ocean, but you average over a year, that it could be a lot. But even if I don't know, the organisms know, right? They can tell you. So you can, it's a degree and a half of average annual temperature difference can tell you something. Let the critters tell you what that means, and that it's enough to sort of allow the persistence of these formerly rare species. So using the biology together with the physical measurements like temperature is pretty useful. So we see this. We saw this with the swimming crab as well, really closely related to the East Coast swimming crab, Calanectes. We saw it becoming more abundant during the El Nino event, and it decreased, but importantly, it was still around. This is one of these things as well that would typically only be around for a year or so, then you wouldn't see it. We're still seeing it. And this area that we're looking at here in Southern California, Northern Baja California, the Bight of the Californias, sometimes called the Southern California Bight, but I think Bight of the Californias is better, sort of the US and Mexico, is a good place to look for patterns because it's a transitional area where you sort of get warmer species from the south and cooler species from the north. And it's a good place to try and pay attention to what's happening with things like tropicalization. So during this period of warming, at the same time, and this is from our minnow trapping data, we saw a pretty substantial decrease in what was one of our most common crabs. It's still around, but the numbers have gone down. And this is Hemigrapsis oregonensis, which is a cool water species. Its range is up into Oregon and beyond, as the name implies. So it's not just warm water species increasing, it's cool water species decreasing is part of this tropicalization signal. So all of this so far has been species that are already around that are becoming more abundant, which is a part of tropicalization. But we also see species that are new to the area appearing. And what I've talked about before was our monitoring through our long-term monitoring programs, which is great. but the community of scientists and naturalists and observers out there is remarkable. And platforms like iNaturalist are a great way for us to see what's going on and help keep tabs on things. And one of the creatures that has appeared in Southern California is this relatively large fiddler crab, Uca princeps. It was sort of known from mid-Baja, California, sort of the end of its old native range for quite a while. And someone actually went into iNaturalist and put a record in there from 1994. In 1996, in 2016, again, during this warm water event, it was being seen in Ensenada area in sort of just south of the border here, and it first appeared for ever in the US in 2018. And it was iNaturalist, and I got an email like, hey Jeff, there's this iNaturalist record of this tropical crab, you should see if you can find it. And we went out and we did find it. And actually someone wrote a paper about the expansion, Michael Rosenberg, based on this sort of iNaturalist record. So these community-based records are a really useful tool for finding new things. They're also useful to seeing if they'll stick around, because it's one thing for something just to appear, that's the arrival phase of invasion, but to establish it needs to stick around and reproduce for a while. So we can look at the iNatural record and say, yeah, 5 years later, it's still around. The last one was just reported last month. So again, these community-based tools like iNaturalist are really powerful. Okay, so what? So why do we care about all this? I mean, I care because I'm a scientist and it's interesting, and there's a lot we can learn. But there's this growing discussion in the scientific literature, the popular press, newspapers, radio, whatever, about what, we sort of live in a post-wild world, right? We're gardeners at this point. We've changed things so much that we don't really need to worry about where things are from anymore. We just need to worry about what it's doing. Whether this is non-native species sort of being moved in from other parts of the world, or even migrations, this sort of tropicalization, this warm weather expansion. And I don't completely disagree with this. And sometimes people try and label invaders as good or bad. Sometimes that's productive, but often is not, because it completely depends on the context, right? I try not to label invader equals bad. Maybe the beetle we would look at and say, okay, it does enough bad stuff that's problematic, but we certainly need to recognize that there's non-natives that are important. The honeybee is non-native in the Americas. It's native to Eurasia, Northern Africa. But there's a lot of concern about this thing disappearing and losing the service of pollination that the bees provide. Similarly, wheat is non-native. Unless you're gluten intolerant, you probably don't want to eradicate wheat. So invader doesn't necessarily mean bad. But on the other hand, I think that origin does matter. And it behooves us to think about this invasion and this sort of this process. And there's a variety of reasons why to believe that origin does matter. One is ecological and evolutionary novelty can lead to surprises. When you put something new into an area, it can have unpredictable responses. And I've already given some example of that. Invasions can erode the uniqueness of systems. For tropicalization, what we're seeing is the tropical zones expanding and becoming more similar, tropicalized, and the temperate and polar zones squishing, right? So that's in some ways eroding the uniqueness of system. But where this really comes into play is for these introduced species, the ones that we're moving around. In a really real sense, Tokyo Bay is looking like San Diego Bay, which is looking like Sydney Harbor, which is looking like much of the Mediterranean. And we're losing diversity at this global scale, and we're homogenizing the Earth's biota. And when we're thinking about global climate change, we know that diversity confers resilience, and we don't want every system on Earth looking the same and acting the same. We need sort of this uniqueness of different systems. So in that sense, origin matters. We know that invaders can impact resident species and transform ecosystems, and they certainly can present new management challenges, whether it's a species that we've moved in and introduced species, or these warm water species, this tropicalization moving north. And so for the next little bit, as I wrap up, I'll talk about some of the potential management challenges, maybe not a lot of them realized yet, but things we should be thinking about in relation to this tropicalization idea. So the first is that as these warm water species move north, they can present new habitat and species management challenges. As an example of this, we did some work in northern San Diego County at Bataquitos Lagoon, where we did some climate vulnerability assessments. And we did that through a scenario planning exercise, where we essentially created these plausible narratives of what the future might hold. These aren't predictions, but these are internally consistent, plausible things that might happen in both the near term and the long term, so that the managers can begin to think about how they might respond. So one of the things that this group we assembled, which included geographers and physical scientists and engineers and biologists and climatologists and all sorts of people, one of the things that they considered was this issue of warming. For example, the gold-billed tern is a largely warm weather species, and its range in the U.S. is basically the Tijuana Estuary and San Diego Bay. It barely moves into San Diego County at all. It's not common anywhere, but it's found further south. And the thing about the gold-billed tern is it eats another rare species, the California least tern, and it's a real management headache that people in Bataquitos don't have to deal with yet, because you have one rare species eating another, and you have the gold-billed tern people, debating the least tern people and how are you going to deal with this. Bataquitos, they've not had to deal with it, but if it warms and the gold-billed tern is going to establish itself further north, they might have to consider that. We also talked about these normally itinerant sort of rare species associated with El Niños becoming more common. And we even thought about, in the long term, there's marked shift from temperate to tropical species, and particularly things like mangroves, right, which is a forest. And it sounds maybe a little, for folks who know this area down here, it sounds maybe a little far-fetched to think about mangroves here in Southern California, but there is a non-native mangrove from New Zealand that actually is established and needs to be knocked back in Mission Bay here in San Diego. And about 4,000 years ago, there were mangroves around. There is mangrove pollen, so it's not completely unheard of to think of that we could get mangroves. And mangroves are great, but they are completely different habitats than salt marshes, right? They're forested, thick vegetation types that are very different than the low-lying marsh. And the species that mangroves support are very different than the species that marshes support and the species that we manage now. So this could be a definite management challenge. I think we might have a little time, but it's worth thinking about. And one of the things, the useful approach is sort of in this binational context, is sort of go to areas where at the northern limits of the current distribution of mangroves. And in Baja California on the Gulf side, it's like LA Bay, Bahia de los Angeles. And look and see what's going on there. It's almost a space for time comparison. You might be able to learn something about the marshes of Southern California in the future by going to look at some of these marshes in Baja California right now. So again, it might be a little far off, but it's worth having on the radar screen at least. So warming might affect fisheries, both commercial and recreational. In Mexico, two of those species that are becoming more common here now, the swimming crab and this big yellow-legged shrimp, are important edible species. but they're not managed as such in the US now. They're just not common enough to even think about management. But if they start to become more common, we may have to consider that more. And here's a chance where we could work with our colleagues in Mexico, where they do have, these things are common and they are a fishery resource and there are management plans. Or for this shrimp that's becoming more common, there's been proposals to do aquaculture with it in San Quintin, a few hours south of here, growing this in a sea lettuce. So these are things we might have to think about. If these desirable species become more common here, we might have to think about how we're going to manage them. And similarly, for sort of recreational perspectives, there could be more tropical species moving north, which could be a boon for sort of recreational fishing. There's certainly concern about public health and tropicalization, especially with things like mosquitoes becoming more common, and mosquitoes that carry tropical diseases and stuff you really don't want, like yellow fever and chikungunya and Zika and dengue and all of these things. And we do have now in California at least 3 of these Aedes species, these warmer species that have established within the last decade or so. Now, they're not transmitting the diseases yet locally because we don't have enough people that are infected, thankfully, with dengue and chikungunya and Zika. But the mosquitoes are here and they're moving around. So public health officials are definitely keeping an eye on this. And there's actually an interesting interaction with this freshwater issue I mentioned a while ago. And as this imported water, either in Mexico or in the US, where we divert the Colorado and the Sacramento San Joaquin down to Southern California, it inevitably slobbers off the hillside, causes this urban drool that we call it, and can facilitate mosquitoes as well. So there's public health challenges associated with tropicalization. And as I mentioned before, with invasions, you sort of expect the unexpected. So sea snakes, yellow-bellied sea snakes, there were a few of them found during the last El Nino in 2016. And just a couple of weeks ago, I got this email sort of on a Sunday night to the state parks lifeguards saying, okay, there's another El Nino brewing. Just keep an eye out for these sea snakes, partly because it could be a public health risk. Now, they're not very aggressive, and most of the ones that wash up aren't in very good shape, but I wouldn't want to handle one of these things, even if it was sort of almost on its way out. They are quite toxic. So this is sort of an unexpected thing. I was not expecting this email like, okay, watch out for sea snakes on the beach and make sure people don't pick them up. Now, some of this is also being led by folks at the LA Natural History Museum who are interested in the distribution of these and tropicalization. Sort of another unexpected. Another thing that was interested in these sea snakes when they were around a few years ago were dolphins. So in San Diego Bay, the military trains dolphins for military things, and they have them wired up with GoPro cameras, and they swim out in the bay and in the ocean. And what they found during the El Nino event was that these sea snakes were eating, these dolphins were actually eating sea snakes which were swimming around and apparently squealing with delight when they ate a sea snake. From what I understand from the paper on this, no dolphins were harmed by eating the sea snakes. Sea snakes were harmed, right? But this is another unexpected. I would have never expected dolphins eating sea snakes off the coast of San Diego. Yeah. Okay, so just to wrap up then, and hopefully one of the things that has come out is this idea that the events that are currently rare or extreme, such as the mid-2010s heat wave, the blob, and the El Nino, or this El Nino that's brewing right now, will become the everyday or become much more common in the future. And if we're out there paying attention and monitoring and keeping track of what's going on, we can help get a sense of how the future might unfold. Again, there'll be surprises to be sure, but we need to be paying attention to these, what are sort of extreme events now. as these glimpses into the future, both in terms of what's happening, but how are we going to respond to that? Okay, so just wrapping up, I just want to thank a number of folks, particularly Dr. Julio Lorda, a friend and colleague, who was on the podcast with me about this issue. We've been talking about this tropicalization thing for a while. He's an adjunct scientist with us at the Tijuana River Reserve, did his postdoc there, and is now a professor, been a professor for a while at UABC in Ensenada, and was one of the co-founders of MEXCAL, Management of Ecosystems Across the Californias. So thanks to Julio for all the discussions and the sharing of data and the ideas and making some of the graphs that I presented. And again, just a whole boatload of people have been involved in funding us and supporting us and working with us. And I won't go through all of them, of course, but just, you know, this has gleaned a lot of information from a lot of different people. And at the Research Reserve, we sort of pride ourselves on partnerships as making us tick. And that really is the case. And I will be happy to answer any questions. Thank you.
Thank you so much, Jeff, for that fascinating discussion of tropicalization. We will now open it up for questions. So if you have any questions for Jeff, please type them into the Q&A box if you haven't already, and we will get to answering those. Bradley, did we have any questions that came in during Jeff's talk?
Yes, we did. I guess the first question is, what can people do to support the Tijuana River National Estuarine Research Center? I know you mentioned iNaturalist. Is that the best way to support the research center?
Yeah, well, what a nice question. Yeah, thank you for asking that. Yeah, there's many different ways to support us, I think. And again, I appreciate the question. As you mentioned, you know, part of that is just being out there, having eyes on things and helping us keep track of what's going on is a huge value for us. And, you know, in terms of sort of more direct support, you know, we're very much a partnership program. So first off, just even being aware of what the National Estuarine Research Reserve System is a big boon. There's 3 of these in California, one in San Francisco Bay. The state partner is San Francisco State University. Each reserve has to have a state partner. Elkhorn Slough Reserve is California Department of Fish and Wildlife, and our partner is California State Parks, and working with our nonprofit. So being aware of the program and supporting and thinking about the partnership, and whether it be parks or Cal Fish and Wildlife or the university, would be great. And, you know, in general, if you're more interested in more information, the Tijuana River website, turner.org, the email, there's more information about the site and our nonprofit partner, the Southwest Wetlands Interpretive Association. So again, thanks for that question. That's very nice.
Thank you. You mentioned your Divided Together podcast. What is the best way to listen to that?
I think we're going to share a link to that, but it's also available on this trnerr.org website. So there's links to the podcast on that website, but I think we're going to share that link.
Yes, we will. And are you still releasing or recording more episodes of the Divided Together podcast?
That is a good question. I believe they are. Yes, that Anne-Marie, sorry, couldn't be here today. I believe they are still working on those.
Great, thank you. Another question is, are these sea snakes having any other significant impact on the local ecosystems?
Yeah, that's a really good question. You know, they're so rare, it's hard to imagine, but even, and I think the sum total that people know about is probably less than 20, but that's why that dolphin example is interesting. in that demonstrates not just that there's sea snakes around, but they're sort of around enough that something's eating them. Now, again, these are dolphins, associated with military, but if they're around enough for, these captive trained dolphins to be finding, there could be more for others. So it's not something that I would have ever said like, oh yeah, it's so rare, and when they get up here, they're in pretty bad shape. But perhaps, and again, there's folks at the LA Natural History Museum who are working on this and thinking about this, and the ones who are making the plea that if people find these, to let them know, to safely alert people. Don't try and pick it up yourself, but let them know. So yeah, folks at the LA Natural History Museum are trying to keep tabs on that.
Great, thank you. We have another question. Is the Asian date mussel from a warmer environment than San Diego?
Oh, yeah, that's a good question. The one that near and dear to my heart. Yeah, I did most of my master's and PhD on that critter. It has a very wide temperature range, like a lot of these non-native species. It's found actually from southern Siberia all the way around into the Red Sea. So it has a huge temperature tolerance in its native range. So I wouldn't call it a tropical species, but it is one of these very sort of tolerant species that can handle all sorts of temperatures.
Thank you. And related to that, I know the California Department of Fish and Wildlife has a page about invasive species like the zebra mussel and nutria. Are those species affecting your research reserve?
The nutria, no. Nutria is definitely in becoming more common in further north. It's not quite wet enough, soggy enough for nutria down our neck of the woods. It could probably handle the temperature. They're in the Gulf. So nutria is a large rodent, maybe the largest, well, a large rodent that can really do a number on ecosystems. The other, sorry, I just forgot. What was the nutria, and what was the other one?
The zebra mussel?
Oh, zebra mussel, yeah. So there's a couple species of the mussels, the zebra mussel and the quagga mussel. The quagga mussel has been found in San Diego County. It tends to be more fresh water. So it is found in some of the reservoirs and some of the, primarily the reservoirs here in San Diego County, but it's not really impacting the reserve itself. It's too salty in our neck of the woods.
Thank you. Another question, at what point does a non-native species become adopted? Or when does it change to a species that we accept? Or
yeah, that's a great question. And that's part of what's fun about, I mean, yeah, why I like this field, partly because there's not a great answer, right? And what's intrigued me about invasion since I started working on them is, because they are natural, there's a lot of scientific information that we can get by studying invasions. Again, they're natural, species move around. So what happens when you put something new into an area? So there's a scientific side of it. Then there's the management side of it, and even into ethical sides of it. And what do you call these things, and how should you think about them? So operationally, the definition I tend to use, and several of us tend to use, is basically for these non-natives that we have moved around. If we believe humans are the cause of it, we would still call them non-natives, or like as an operational definition, or invaders, that sort of thing. But that doesn't necessarily mean to confer that it's a negative. So I think it completely depends. There's probably not a set answer for a certain amount of time, but I think it completely depends on the context. Again, honeybees are non-native, but there is great concern about losing them. So I think you can't separate out the species from the context. Now, and again, I don't like to label invaders as good or bad. Again, sometimes we can deem them as problematic and maybe even want to try and eradicate them. I think that that's sometimes just necessary, especially if they're compromising a native species. What I do say is bad, though, is the process of invasion, especially this unchecked, willy-nilly, just moving species around. You dump a bunch of ballast water into San Diego Bay that might have larvae of or adults of 100 different species, and we're playing ecological roulette. I think that is bad, and that's a problem. The species themselves, I think you just have to separate it from think about it in context. And frankly, sort of like what I was talking about before about, origin doesn't matter. I think as we get into an area of climate change and thinking about living shorelines and what we're willing to tolerate, if a non-native species it's going to challenge some of our assumptions about whether these non-natives are good or desirable or not. So again, I support some of the arguments that those folks have about, invaders can have benefits. I definitely agree with that. I just think that origin matters. Yeah, that's a really wishy-washy answer, but I don't think there's there's probably not a clean definition, but we have to understand it and consider it in context.
Thank you. We have another question about non-native species, and you spoke a bit about mosquitoes. Do you find that these will change our lives too as humans due to the change in species?
Yeah, well, I do. Diseases aside, certainly if they start transmitting these tropical diseases, that'll be an issue. But having lived in San Diego for a while, for whatever reason, I knock on my wood desk here. I don't seem to get bothered by mosquitoes too much, but my wife does. And I first it's all right. Then it's like, oh, wow. And the mosquito situation is worse here than it used to be. These 80s species, these new species are called these ankle biter mosquitoes. They tend to fly kind of low. And it's definitely buggier here than it used to be. I tend to not want to make sort of qualitative observations too much, but I believe that is true. And a lot of these species are container breeders, so they'll live in tires or even like a small pot that's holding in the water. So they can very much live in urban areas. But I think it's already affected things. It's buggier here than it used to be. I don't remember ever being with folks that wanted to head inside because of the mosquitoes here, but it's starting to get that way. But yeah, and if they start transmitting diseases, then that'll be next level.
Thank you. We had another question. I know Borderfield State Park is within the research reserve. Is that park open for visitors?
Yeah, that's a very good question. And there's actually a warming tropicalization thing there too. Is that tropical storm that rolled through messed up the road down there. So there's still some trees and stuff on the road. Plus we've had some issues with transboundary flows of sewage contaminated waters across the road there. So I believe it is not open as of now. Typically the park is open even to vehicles during the summer months when it's not raining. Once it starts raining, the roads essentially become channels because of all the sediment that's accumulated down there. But we try and keep it open for pedestrian access. But yeah, there's been a confluence of the rain and the storm, and some infrastructure problems have caused some access issues. So Borderfield is, I believe, not open now. They're trying to open it, but once it starts raining, it becomes a whole nother challenge. I'll just say on that, this a whole nother talk that I won't give, but there's a lot of effort to try and increase access and improve people's ability to get to this really important spot. It's the southwest quarter of the continental US, or as my friends in Mexico say, no, it's the northwest corner of Latin America. It's like, okay, fair enough. So we're working on it, but there's definitely challenges, and State Parks is pushing hard though.
Thank you. Another question, I know you spoke about El Nino and maybe other climate change affecting species, but do you envision additional tropical storms making landfall and bringing more non-native species to the region?
Yeah. Well, I think we can probably expect more tropical storms. And tropical storms, that's a good question. I haven't thought about this much. This is kind of fun. It was such a wide-ranging talk I gave that I'm covering a lot of ground and making me think about things I normally don't, which is good. In some areas, tropical storms are known to move species around, and species can be transported with the storms themselves, besides just sort of the warming conditions. So I suppose it's possible. I mean, one thing I'll just mention is that here on the West Coast, we don't have the density of sort of like our coastal wetlands that I think about are fairly low. And I think that's part of the reason why mangroves may have a little harder time to get up here, is that if you look at the distribution of coastal wetlands in Baja California, and up into California, it's relatively low. If you look at the East Coast, it's basically continuous wetland, or is mapped as such, all the way up the coast. And there's good examples of mangroves just sort of progressively marching further and further north. Every year they move a little bit more. That mode doesn't perhaps work here as well, because there's fewer systems, and there's a lot of sort of unhospitable habitat for wetlands in between. So you have San Quintin, which has a nice wetland, then it'll be 100 miles, and then Ensenada, and then there'll be another gap. But I think it is possible that these tropical storms could move things around. Maybe not to the extent they could on the other coast, though.
You. We have another question. Should we expect more green sea turtles or breeding here in the continental US?
Yeah, totally not a turtle guy. But I think that, I mean, part of that is the suitability of habitat, and part of, like, temperature wise, some of that is the quality of that habitat. So there definitely are resident populations of sea turtles, like in the south end of San Diego Bay, which tends to be kind of warm, and actually had a power plant discharging into there and warming waters. And there's resident sea turtle populations elsewhere. So I would think that warming could potentially facilitate this, but it's Southern California, right? And there's so many people, and it's the other element is sort of the anthropogenic influence of these systems. Even if the water temperatures are right, it's so heavily urbanized that could have a sort of a chilling, as it were, effect. Again, I'm speculating. This isn't my area of expertise, and if there's turtle folks listening to this, I apologize, but that's my quick take.
Thank you. Another question, are there any international or binational efforts to combat tropicalization?
Oh yeah, that is I don't, that's a good question. Well, in general, of course, trying to combat the thing that might be causing it, warming, certainly receives a lot of influence, a lot of attention, needs more. It's a good question. I don't know of, I don't know. I'll have to look more into this. I think it's sort of early enough that my impression, at least on this coast, is that sort of early enough, we're just sort of seeing the first signals of it. And people, have to make, there'll be choices to be made. Like, for example, I don't think where the mangroves are moving north on the Florida coast, they're trying to eradicate the mangroves where they're appearing. But there will be choices to be made. If mangroves do appear in Southern California, they won't support ridgeways rails, clapper rails. So I don't know but they're not doing it now, that they're going to have to think about it at some point. And again, there's probably not a prescription. I just very much on the, like, you must do this or that. I'm very much for, especially as a scientist type, trying to provide information and as much information as possible to make what are hard decisions. And those decisions might vary depending on where you are or what you're trying to do, but it's best informed by as much information as possible. And folks who have thought about invasions and thought about sort of species relationships can help inform those conversations.
Thank you. Another question. I know you spoke a bit about rare edible species being introduced, but have you heard of any, opportunities or commercialization done to introduce species for the marketplace?
I mean, in terms of the tropicalization, no. I mean, well, again, here on this coast, which is on what I'm most familiar with, I mean, again, they're so rare that I don't think it's been sort of into the marketplace. And I don't, again, in Southern California is so urban. I don't know how many that, if there would actually support sort of marketable quantities of these, but perhaps. But there are certainly other cases, like for the Pacific oyster, for example, this non-native Japanese oyster, it's appearing all over San Diego Bay. And there's been studies, including by sort of anthropologists at the University of California, San Diego, it's potential food resource that didn't used to be there, that is now growing. But there's potentially concerns about eating. I would be a little concerned about eating a filter feeder out of San Diego Bay, right? So there's definitely been some thinking around this, and there are programs to try and eat the invader. That's somewhere I have a book about, like, it's called Eat the Invasives. For example, trying to put, like, on the East Coast in Caribbean, the lionfish, a very charismatic, very successful invader. They're trying trying to serve lionfish on menus and things like that. I don't know how successful it can be knocking the things back, but it is something people have tried.
Thank you. We have another question. Does sediment affect tropicalization? Does this change maybe how species or non-native species survive in an ecosystem?
Yeah, does sediment?
Oh
yeah, that's another good question. One I'll have to be careful not to go on and on about. To the extent that which it changes. So the primary impacts of the Tijuana River Reserve are water, just the water itself, as I mentioned before, not necessarily negative with growing the trees, but what's in the water, sewage, pollution and the trash, but also sediment. So to the effect that, what I would think about in a wetland system is that if sediment's coming in, it can essentially transform the ecosystem from a wetland to an upland. If you get enough sediment coming in, which we do in Tijuana, the river from the hillsides of Tijuana, it can essentially convert it to an upland habitat. And I could see that interacting with we definitely see more non-natives when elevations increase. We don't have a lot of non-native plants that can live in our salty, high salinity environments. But when you see the elevations increase, you definitely see more non-natives associated with that, because we have a lot more weeds and things that can handle the somewhat less wet, less salt environment. And I had someone who works for us, Kelly Ueda, did her master's on that, looking at sort of elevation, and increasing in elevation including due to sediment, can facilitate non-native species.
Great, thank you. Just a couple more questions.
Okay, you're great, good.
What are the best ways that individuals could, help combat climate change?
Oh, yeah. Yeah, right. I mean, think globally, act locally, oh yeah, that's, I mean, any, yeah, almost anything you can think of at any level probably is appropriate from trying to enact and support people who are making policy decisions either internationally or nationally within the state or locally, who would view this as an important issue that needs to be dealt with sort of at a top-down sort of government policy sort of level, just to the little stuff, right? Solar panels and it's hard and it's easy to feel guilty. I should be doing more, but I think all that little stuff can add up. Right, but it is important to think about, and we certainly need to be doing more of it. And obviously, as a society, I think collectively, I'm a little surprised we're not all behind it more. But I think it's going to become apparent here that we need to be.
Great, thank you. Got a couple more questions just came in. So it looks like people are looking to the restoration of wetlands for the mitigation of climate change.
Oh, yeah.
Can you comment on how maybe invasive species can interact with this function?
Yeah, that's a good point. Yeah, again, I'll try and keep it quick. But basically, coastal wetlands, including salt marshes and mangroves, are about the best ecosystems on Earth for trapping carbon away and keeping carbon away. Rainforests and things like that trap a lot of carbon, but eventually some of that carbon or a lot of that carbon can end up back in the atmosphere, either through plants eating or animals eating the plants or fires or that kind of thing. Because wetlands are soggy, they tend to trap sediment. Most of the carbon that ends up in the salt marsh gets shoved underground, is below ground biomass. It gets buried into sediment, doesn't really burn because it's wet. Salt water inhibits methane production. So wetlands are great for doing that. Sort of back to the last question, even though they're the best ecosystems on Earth, and we need to conserve and protect these, probably not enough. I mean, it's asking too much. When you see how much a car emits in carbon, or when a gallon of gas is less than a gallon of bottled water, right? The market for putting the carbon in the atmosphere is not equal to the market for trying to get it back in the ground. So when we do our restoration, which we definitely are working on, we talk about this as carbon capture as one of the important things we're trying to accomplish, but not the only thing. We need to think about carbon capture as the suite of different things that wetland restoration can do. And thinking about invaders interacting with that, at least in Southern California, we're fairly lucky that in terms of these major habitat forming plants in the marsh, we don't really have that many non-natives yet. But we need to so we can largely do our restoration. Now it'll have non-native animals with it and Asian date mussels, and that's just part of the equation. But these major habitat altering things that come in, we don't have. Now, San Francisco North has invasive hybrid Spartina cordgrass. There's invasive seagrass, but those aren't down here yet. So we would like to keep those things out. And I mentioned there is an invasive mangrove in Mission Bay, a warm water mangrove, intentionally imported from New Zealand by a researcher who was looking at photosynthesis And I don't think the idea is that it would take, but it did. And it's not a huge issue, but it has to be knocked back every once in a while. So there's an instance where invasive species is potentially compromising restoration activities. And there's others as well, but largely we can do restoration without worrying too much about these major habitat transforming invaders coming in. And we like to keep it that way.
Well, that is all the time that we have for questions. Thank you, Dr. Jeff Crooks, for your very informative answers. We all really appreciated your time and effort.
Yeah, sure. Yeah, my pleasure. No problem. And again, there was a question about the podcast. I think let's see the link in the chat. And again, sort of where you get your favorite podcast, it should be on there. So yeah, thank you for the invitation.
Thank you again so much to Dr. Jeff Crooks for his wonderful presentation. Thank you to Bradley Siebold for monitoring our Q&A. And thank you to all for attending. If you're ever in the area, please consider visiting the California State Library at 914 Capitol Mall in Sacramento, Monday through Friday from 9:30 a.m. to 4 p.m. We hope you will also visit your local library to check out a California State Library Parks Pass and visit one of the many beautiful state parks in California, such as those found in the Tijuana River National Estuary Research Reserve. Thank you all again for attending and have a great evening.